It's a pleasure to be here with the India Electronics and Semiconductor Association. We're in the era of the edge. It's poised to drive growth and prosperity. At the heart of edge computing is semiconductors, and all of us in the industry have an opportunity to influence the direction this will lead us. What direction are we talking about? The number of devices are going up. 50 billion are expected by 2025 worldwide, but they need to be purposeful. The purposeful growth requires us to ensure these devices deliver the ultimate goals for society: greener, more productive, more safe. To accomplish these values, let's look at how the 50 billion devices can be used. Everything and everywhere, from the cloud to industry and to healthcare and to transportation and into our homes, this is the edge of everything. And it has tremendous potential to transform our lives while accomplishing the social values we just spoke about. I'm excited to talk about these visions with you, all because India, and in particular the semiconductor value creators in India, can play a pivotal role in this transformation. What I mean by this, it's two-way. It can help India grow faster and bigger, and India can contribute to the world's growth. Let's go deeper into some of the key edge applications that can be transformative. Starting with smart agriculture. This is a very critical area because eliminating hunger is a key goal of society, and it's a UN sustainability goal. And with the growing world population, food production must increase 60% in the next few decades. But smart agriculture is not just about producing more food. Instead, we need to adjust production in a way that is more sustainable and better for the environment. This means optimal use of water, less fertilizer, and less pesticides. It's not always intuitive to associate edge processing with agriculture. On the contrary, it brings a lot of opportunity. Think about farming. Vast quantities of water and fertilizer are often distributed across fields, leading to wasted resources. And historically, as a society, we've used our generational knowledge of nature. It's the rainy season from June to July, so we don't water. But we don't have to depend on that knowledge and hope it is correct year and year. Here's where the edge comes in. Edge processing can collect enormous amounts of data and process it locally in real time so that decisions about irrigation can be made specifically for a field, the type of crop that's being cultivated, and the climate. These data-driven insights can lead to improved soil health over the longer term. The same applies to fertilization and the use of pesticides. Instead of applying a general set of rules, you can use drones, for example, to capture images so you target areas that need it. This also leads to greener, healthier, and more productive farming. Farmers with even limited internet access can still reap the benefits from edge processing without always having to send the data to the cloud for analysis. Farming is also about dairy management. The edge allows you to do personalized care of the livestock. You can get individualized, real-time insights on every cow's location, movement, milk production, fertility, health, nutrition, and so on. It can wear a sensor that tells us its well-being. We can adjust what it eats for a healthier and longer life. Again, we move away from a generalized set of rules and we personalize it for optimum results. This is where the world's heading. Many countries are adopting edge capabilities to dramatically improve agriculture. It's equally important for India as well. In just a few years, India is projected to be the most populous country in the world. And about 50% of India's population is dependent on agriculture. When it comes to dairy production, India produces more than 20% of the world's milk output, making it the largest milk-producing nation in the world. And with growing population, the demand only increases. Without sustainable systems that make production more efficient, the divide between those who have enough food and those who don't will continue to grow. Edge computing for agriculture will be critical to meet the demands. Let's move to the production of the goods, the industry. It's the backbone of a growth engine for any country's economy. In the last 3 centuries, we've seen 3 generations of the Industrial Revolution already take place. We're currently in the 4th generation of the Industrial Revolution, commonly referred to as Industry 4.0, and we're on the brink of Industry 5.0. Both build upon the foundation of edge processing. Manufacturing systems and other operational technology and information technology are converging. This is Industry 4.0. In this era, real-time systems connected by wired and wireless are working seamlessly on a factory floor to maximize output. Connected machines make the day-to-day overseeing of operations of the factory floor easier. For the operators, it's improving safety and ease of operation through interactive and informative displays. Machine vision is now adding eyes to the robots, which were purely mechanical before. In the past, robots needed to be programmed for precision movements within a 3-dimensional space. With machine vision, we've given robots eyes to be less dependent on precision programming. This makes them more agile, and they can make decisions locally in real time. As a result, this can dramatically improve productivity and worker safety. It's not just that. Machine vision is also helping with quality control because precision imaging and processing at the edge is more accurate, more discerning, more faster than a human eye, and it's not subject to fatigue or human errors. It is tireless. Adding ears to these machines in the form of microphones, we can learn from the sounds they make. With machine learning at the edge, any deviation from an established normal range can be detected as an anomaly. This moves us from an era of preventative maintenance where machines were shut down at predetermined time intervals, whether they needed it or not, to an era of predictive maintenance that targets only those machines that need attention. Industry 5.0 takes it to a next step where robots will cooperate and function alongside humans for maximum productivity and safety. These cooperating robots are called cobots. Just like the rest of the world, India has the ambition of explosive industrial growth. When I was asked to do this keynote, I read up on the Make in India initiative. Edge processing is a key enabler to achieve these goals. We spoke about food. We spoke about smart manufacturing. Now let's talk about health. Whether it's a health worker's diagnostic kit, an insulin pump that precisely manages blood sugar levels, or a heart rate monitor, all of these are made possible by edge computing because of its real-time response. And you don't need a connection to the cloud. In fact, some industry experts estimate 75% of the medical data will be generated at the edge by 2025. If all of the data is accumulated and has to be maintained in the cloud, it then becomes an attractive target for bad actors. Ensuring integrity and protecting privacy of all of the personal data is a national responsibility. Edge computing helps make this possible. Another revolutionary use of edge computing is bringing health services to the local population. What do I mean by that? A lot of patient diagnostics and care can now happen in mobile medical camps with edge computing tools and capabilities. This happens on-site in a real-time basis. You don't need to wait days or weeks for a remote lab to send results back. And in countries with vast populations across rural areas, this would be a game-changing advancement in healthcare. The COVID-19 pandemic has exposed the urgency to create such a resilient, fast-responding healthcare system in every part of the world, including India. Connecting ideas and people has a multiplying effect on innovation and growth. As a society, we need to harness this possibility. Seamless connectivity is helping us achieve that. But it's not just about mobile phones. It's about bringing the world of data to people, to the network edge and to the device edge, and even to the remote parts of the country so that everyone benefits. But how do you build the infrastructure? Two things you need are cost-effective implementation and enough bandwidth to serve the needs of the people and the machines. This is where 5G comes in. Part of the reason 5G is revolutionary is that it has the potential to increase bandwidth tenfold compared to its predecessors. And with connections provided by large cell towers to tiny small cells, 5G capacity can be tuned from urbanized regions to small communities. Countries like India lead the way in 5G rollout. Ironically, this is because there is not an extensive legacy wired infrastructure that extends into rural communities. This opens the opportunity to invest in wireless infrastructure like 5G. Semiconductors are at the heart of the 5G revolution, from the wireless modems to the interface between the real and digital worlds. I want to leave you with this. It was estimated that in 2019, the number of internet subscriptions in the rural India was less than 30% than in the urban areas. This is a large gap that has to be bridged in order to fulfill the path of connected communities. 5G is the easiest path that we know of to connect these areas. Edge devices need to be built for today's needs and be capable of handling those of tomorrow. So to fully realize the edge computing potential, you need three fundamental capabilities: energy efficient processing, actionable machine learning, and seamless connectivity, all built on a foundation of uncompromised security. First, energy efficient edge processing. Energy efficiency simply means using less energy to perform the same task. That is eliminating energy waste. We can reduce greenhouse gas emissions and lower our energy costs on a household and economy-wide level. Energy efficient processing requires clever SoC architecture that can exploit the advantages offered by process technology. For example, at NXP, we've used FDSOI technology to achieve ultra-low power performance. This is particularly ideal for battery-operated devices like wearables. Where high performance is paramount, at NXP, we've used FinFET technology, but we've also included low power real-time domain for sensing functions so the overall system power could be kept low. You also need seamless connectivity. Though the usual question is, which connectivity technology is the best? Well, there's no one protocol that covers every use case. You may need to tap into ultra short range to wide area coverage. And in some cases, such as a factory automation, you need a combination of wired and wireless connectivity. Legacy wired networks in existing factories cannot be easily replaced, and new wired networks will use fast-growing Ethernet-based time-sensitive network for IT and OT convergence. But still, the complexity and the cost of wiring is a deterrent for mega factories. This is where a judicious addition of 5G, which offers low latency and high bandwidth, brings flexibility, connectivity to these factories. So whether you're connecting devices throughout your smart home, connecting wearables to the cloud, or connecting factories, you need to find a connectivity solution to fit the application. I mentioned earlier that we anticipate 50 billion smart connected devices by 2025. By then, data creation in the world is projected to grow to more than 180 zettabytes. That's 180 followed by 21 zeros. This enormous amount of data should be put to good use with actionable machine intelligence. With this intelligence, we can have a more human-like experience when we interact with machines. They recognize us, recognize our gestures, and understand the tone of our words. However, we can't rely solely on the cloud to process all of this data. The response time must be fast. Devices should be able to make decisions whether they operate autonomously or they connect to the network. This is where machine learning at the edge comes in. Machine learning algorithms can be deployed on the device itself, inside of the entry access systems, for example, where the data can be processed and kept privately inside of the system rather than in the cloud. Or in a vehicle that is performing automated driving tasks where real-time decisions can mean a safe or a dangerous trip for you and others on the road. Data must be protected to ensure personal privacy. The number of data sources, value of the data, and collaboration of the data are all increasing. Combine this with the growing number of smart connected systems, it makes securing data even more challenging. Therefore, uncompromised security is fundamental. It begins with establishing the root of trust in the silicon. From there, levels of trust can be built all the way up to the application software. A good analogy is online banking. When you open your web browser to your secure online banking site, the browser negotiates and exchanges credentials. You see HTTPS. This means it's a secure connection and the site is authentic because it's undersigned by a trusted authority. The process establishes mutual trust. This kind of established trust also needs to happen for IoT edge processing to ensure data security and privacy. But how do we protect valuable data when it has to go outside of its trusted environment without compromising privacy? Confidential computing addresses that challenge. With confidential computing, you can create secure virtual silos on a single edge device. For example, one silo could be used for sensitive biometrics, while another could be used for face recognition. Now, we can more easily collaborate across networks, which leads to a safe, secure, and collaborative world. India can do more than make. It has an opportunity to innovate and lead in the adoption, to become an example for the rest of the world, to see how technology can propel a greener, more productive, and safer world. When people think about contributions of semiconductors to a country's economy, the first thing that comes to mind is manufacturing. This is especially true in today's world with supply constraints. But that's not all. There are several aspects to semiconductor advancements. It's not limited to manufacturing. Semiconductor design, for example, is one. And India already has some of the best semiconductor design talent. This expertise is becoming even more critical now than ever before, because in many ways, Moore's law is slowing down. The design complexity is dramatically increasing, but at the same time, the need for energy efficiency processing is paramount. So India could lead with the next generation of R&D designers who can tackle these challenges in clever and innovative ways. The other critical component is software, which is deeply intertwined with semiconductor devices, especially for capabilities like security, low power, and machine learning. India already has a strong software talent base to build upon for these emerging opportunities. Adding to this is India's vibrant startup culture. They can innovate to accelerate adoption of edge processing and all of the opportunities that I've highlighted earlier, like smart agriculture, smart manufacturing, smart health, and 5G to connect ideas and people. Where is the semiconductor revolution going? Even after many decades of exponential growth, there's no evidence of it slowing down from PCs to smartphones, and now the era of edge computing. The possibilities are limitless, and everyone here today has a pivotal role to play in paving the path that benefits us all. Thank you.
Thank you, Ron, for that very, I would say, informative talk. And what I found really interesting was your points around, of course, the balance that we have to do between using data for everything that we need today and privacy and other aspects. So there is this aspect of being able to use data to be more productive, but at the same time, now today we are faced with challenges of making sure that the data is secure, it's reliable, and a lot of other things. So in terms of, there's always a push and pull between data availability and making it and ensuring privacy and other aspects. What's your view on how do you balance those two? Because it's a critical component of everything that you just said, right? So how do you see that balance be brought in terms of being able to look at productivity, taking technology to the next step, applications like AI, software, etc. But at the same time, ensuring that security and privacy are balanced. What is your view on that? Yeah, so my next question was around the point that you made about India playing a critical role, because India has the next generation of R&D designers, whether it's around software, security, or embedded, or many of the spaces that today require engineers. Are there some inputs you would give in terms of focusing on certain segments to make sure that there is a strong contribution from the Indian industry in the next generation of technology growth? We are not able to hear you, Ron. We're having some technical glitch and unable to hear what Ron has to say. So just stay tuned, please.
Okay, very good. I can now speak.
All right.
Can you hear me, Sunil?
Yes, I can, Ron. Were you able to get my
Okay.
first question yet?
I could. So let me start with where edge computing can come. It can help by acknowledging or understanding that a presenter cannot unmute on the web conference application. It can then send an instruction to the team that is managing this very exciting conference, and it can automatically, without human intervention, unmute my button, which was locked for me as a user. And it can help in terms of efficiency. So with that said, and I appreciate the opportunity to speak with this community and with you. So you're talking about the balance in terms of data security and then bringing compute and edge, or call it intelligence, in the term of machine intelligence as part of society and work. And it's a critical balance. At the end of the day, the amount of data and the value of the data is increasing, and security is absolutely critical in everything we do with that data. So where there is a significant focus is on how do you authenticate? How do you basically deploy a set of devices that is going to collect information and you're going to use to make decisions that could impact safety, that could impact a company's well-being? And then how do you decommission, and how do you secure the use and access of that data? So that is a thought process in terms of the devices you pick. And in the case of NXP, we spend a significant amount of effort in terms of integration of security, secure enclaves, and excuse me, recent processor, IDMX apps processors, where we've deployed that. We have partnerships with companies like Microsoft that provide security services, and then you use that in combination with the machines, the data collection, and then the actions that you determine. And that's very critical. And then we can get into a whole discussion of how you then use the technology and the processing of data, including confidential computing environments that protect sharing of information and that unique attributes such as personal information, but allows for a greater, I'll call it, purpose in terms of calculating information, but not doing it at the expense of revealing your personal information in those calculations and not giving access to it.
Yeah, so thanks. I think, we clearly pointed out that there's lots of challenges and opportunities in security and guaranteeing the privacy aspects. One other question that we did have from the audience, actually, and this thanks, Ron, for such an insightful talk. This is from the audience, so I thought you should also hear what the audience has to say. And this is truly inspiring to hear that India is a part of the edge of everything. You have brought up a crucial point on the next industrial revolution. Please share your views on what you foresee happening in Industry 5.0. How edge processing will influence tomorrow's industrial revolution? This is a question from the audience for you, Ron.
Great question, Sunil. I really appreciate that. So when we think of Industry 5.0, we're talking about empowering humans on the factory floor and driving industry capability that leads to both safety and sustainability. So it's going beyond just the engineering, mechanical aspects of more efficiently doing a task. And it gets to how do we enable the industry to reduce waste? How do we enable the industry to be more productive, such as food production that I mentioned during the talk? It's bringing in enhancements around augmented reality, the worker of the future who has the ability to have a computer assistance in a very efficient way so that they can diagnose a problem and address it with computer assistance and giving visual overlay on how to do and perform the job in a more effective way. So we get into all aspects of bringing in real-time compute, bringing in HMI, where you have a very comfortable interface, bringing in sensing capability around vision, voice, as well as machine learning content into these environments to really help achieve these broader societal goals that we have, and is critical to all nations and is critical to the world in general.
Thank you, Ron. We have a couple more questions, but I'm afraid we are running short on time. So I will have the audience questions sent to you and your team. So thank you very much for sharing your time with us today. We also want to thank the NXP India team for helping facilitate this talk. I'm sure the audience really appreciates all the thoughts that you shared. And we look forward to strong support from NXP in the next revolution. Call it that.
Very good.
Thank you, everyone. Thank you.
Thank you.
Good evening. Bye.
Appreciate it.